What if I told you we could completely reverse engineer a perfect top band answer and literally steal marks straight from the Cambridge Examiner's mark scheme? Well, zero fluff today. We're skipping all the basic definitions and starting right at the finish line. Let's dive right into this explainer and execute what I like to call the mark scheme heist for Cambridge IGCSE Physics 0625. Check out this typical student response for measuring density. Honestly, at first glance, it looks like a totally standard calculation, right? The student wrote down the formula, plugged in their numbers, got a result. Simple. But they completely missed a crucial, practically invisible step. And in the Cambridge syllabus, that is a devastating mistake. It's exactly the kind of error that makes you strut out of the exam hall feeling like a genius, only to get your results back and realize, yep, you fell right into an examiner trap. I mean, dropping 4 out of 4 marks on what should be a simple measurement question, that is absolutely the quickest way to crash your grade boundary. In practical data questions, every single mark is a stepping stone. Losing all 4 here doesn't just lose your points, it literally hemorrhages the exact, easy marks that separate an A star from a B. So we're grounding today's master plan directly in the official source material. Looking at the Cambridge IGCSE Physics coursebook, specifically sections 1.1 through 1.3, we're talking about measuring length, volume, density, and time. This right here is exactly where the examiner pulls those tricky practical data questions from. So we're going to lock in on the apparatus, the variables, the safety checks, and the table designs for these specific sections. Here's our heist blueprint for today. First, the mark scheme heist. Second, why ordinary revision fails. Third, the perfect answer framework. Fourth, a spot the error challenge. Fifth, examiner corrections. And finally, the escape tunnel. All right, part 1, the mark scheme heist. The big takeaway here is that we are completely abandoning traditional study methods today. Honestly, just reading the textbook from page 1 to 100 is not going to save you when that exam clock is ticking. Instead, we're starting at the perfect finish line, the mark scheme itself, and working backwards to figure out exactly what the examiner's red pen is actively hunting for. Moving on to part 2, why ordinary revision fails. Why does the usual revision fail so miserably under actual exam conditions? Well, because just memorizing formulas, like knowing that density equals mass over volume, is nowhere near enough. When you're hit with practical data, reliability questions, and uncertainty calculations under intense pressure, knowing the formula is literally just the entry ticket. Look at this checklist of common examiner traps. Missing units? Bam, instantly loses you a mark. Rounding way too early in your calculation? That throws off your final answer and kills your accuracy mark. Then there are vague explanations, flipping your graph's independent and dependent variables, suggesting really weak practical improvements, or drawing conclusions completely unsupported by your data. These are the hidden tripwires in sections 1.1 to 1.3. So, part 3, the perfect answer framework. To legally bypass these exact traps, we need a reliable cheat code. You need a system you can use under pressure that literally forces your brain to hit every single mark scheme requirement, every single time. Enter this 4-step framework. It's your absolute ultimate weapon. Step 1, identify the concept. Are we dealing with volume, density, or time? Step 2, extract the evidence or data straight from the provided table. Step 3, apply scientific reasoning to connect that data to physics principles. And step 4, lock it in with exact examiner wording. Don't just say the result looks weird. Say, there's an anomaly in trial 3 that decreases reliability. This exact structure forces you to write the kind of answers that examiners just absolutely love to give full marks to. Now, in a moment, I'll show you the exact examiner clue that changes everything about how you handle practical uncertainties. It completely flips the script. But you've got to master this 4-step framework first, or that clue will be totally invisible to you on exam day. All right, part 4, spot the error challenge. Let's put this new cheat code to the test, shall we? Let's see if you can spot the hidden mistakes in a real exam scenario based on measuring density and volume. Take a look at this comparison. On one side, we have a heavily flawed learner mistake. Notice how vague those variables are? They just threw down some numbers with 0 units attached and made a sweeping claim about the material's density without any real backing. Classic 0-mark answer right there. But look at the top band answer. What's awesome here is the precision. They correctly substituted the values, used standard SI units like grams per cubic centimeter, and even included specific practical steps, like reading the measuring cylinder at eye level to avoid parallax error. That is exactly what a 4 out of 4 looks like. Moving into Part 5, Examiner Corrections. Remember that crucial point we teased earlier? It's all about how the examiner expects you to handle tricky data sets and graph scale rules. When you're looking at practical investigation data, like what we're showing here, the examiner's clue is always hiding right in plain sight. Check out the columns for volume, mass, density, and uncertainty. Notice anything weird about trial number 3? The mass suddenly spikes, totally breaking the trend of the other trials. That is an intentional anomaly, folks. The examiner clue is that they want you to spot it. If you just blindly calculate an average density and include trial 3, boom, you lose the mark. You have to explicitly state that trial 3 is an anomaly, exclude it from your average calculation, and then properly express your final uncertainty using the correct significant figures. That is how you use the data as evidence to crush the scientific reasoning step of our framework. Finally, Part 6, the escape tunnel. Fantastic work so far. You've officially hacked the measurement and data questions. You now know how to structure your answer, include your units, avoid those pesky parallax errors, and spot hidden anomalies in the data tables. But the heist isn't quite over yet. We've left one massive unresolved problem on the table. Sure, you've mastered sections 1.1 to 1.3, but how in the world do you apply this exact same 4-step framework to the hardest evaluate and describe questions in the rest of the syllabus? I mean, how do you handle complex thermal capacity questions or super intense electromagnetism practicals where the variables are totally different? To find out how to beat those, you absolutely must take the escape tunnel to our next explainer on Physics 0625 Common Tropes by Question Type. It is the mandatory next step to completely secure your top grade. Please subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCE to excel in your Cambridge examinations. Click that next explainer right now and ask yourself, are you going to let those hidden marks slip away, or are you ready to finally master the hardest questions in the syllabus? I'll see you on the other side.